Hey everybody, Mr. Reeves with you. We're going to go back and continue. Actually, we're going to finish up looking at IXL practice skills on proportional relationships. All right, so specifically today we're going to be looking at graphing proportional relationships and finding the slope, interpreting graphs of proportional relationships, and writing and solving equations with proportional relationships. All right, so here we go. Skill I-8. Graph proportional relationships and find the slope. Well, make sure you have watched my video or another video on finding slope. Just a reminder, slope is the rate of change between the y variable, the vertical variable, and the x variable, the horizontal variable. When you have a proportional relationship, slope is also the same as the constant of proportionality. So change in y over change in x is equal to y over x. I explained that in the video I made. So again, if you haven't watched that video, please go back and watch it. All right, here we go. Zoe is excited because her grandfather in New Orleans is going to teach her how to make pralines. He makes 10 pralines for each cup of pecans he uses. There is a proportional relationship between x and y. Graph this relationship. All right, so it says he uses 10 pralines for each cup of pecans. Sorry, he makes 10 pralines for each cup of pecans he uses. So cup of pecans here is on the x-axis, pralines is on the y-axis, and it says he makes what? 10 pralines for each cup of pecans. So if we go right here to cup of pecans, 1 cup of pecans is 10 pralines. All right, now unfortunately I can't do 2. 2 would be 20, right? And 3 would be 30. So the only other point I can do here is 0, 0, right? If he uses 0 cups of pecans, he will get 0 pralines. And remember, all proportional relationships must, on the graph, make a straight line, which we are now going to refer to as a constant rate of change, and must go through 0, 0. So what is my slope? Again, my slope is my change in my y over my change in my x. Well, how much did it go up? It went up over 10. How much did it go over? 1, right? So 10 pralines for every 1 cup. So it's 10 over 1, or we can simply put 10. If you put 10 over 1, that would also be correct. All right, Max is finding the perimeter of different size equilateral triangles. He finds that the perimeter is always 3 times longer than the side length. So if it has a side length of 1, the perimeter would be 3, right? If it had a side length of 2, the perimeter would be 6, right? 3 would be 9, and so on. And you notice we get that constant rate of change. It goes through 0, 0, so this is a proportional relationship, right? The constant of proportionality would be 3 over 1, or 6 over 2, or 9 over 3, which also happens to be the rate of change. The change between any y value and the x value will always be up 3 over 1, up 3 over 1. Can you see that? In fact, let me go ahead and just put that. It goes up 3, and then it goes over 1, right? And then it goes up 3 again, and then it goes over 1 again, right? Then it goes up 3 and over 1. So that is our slope, 3 over 1, 3 over 1, 3 over 1. By the way, and again, if you take any one of these points, 1, 3, or 2, 6, or 3, sorry, it's right there, 3, 9, if you did y over x, right, you would get 3 over 1, or 6 over 2, or 9 over 3, which all equal 3. And as we saw, the change in y over the change in x, that's those arrows, was always 3 over 1. By the way, I showed you this in the video. Also, you don't have to use 2 points in a row. If I went all the way up and all the way over that way, right? If I did that one, it would be up 9 and over 3, which also simplifies to 3 over 1, right? And we say that M is the letter for slope and K is the constant of proportionality. In a proportional relationship, those two will always be the same. The slope will always equal the constant of proportionality, k. All right, so the answer we're looking for here is 3, or 3 over 1. All right, let's skip up to the next level and see what we have. The Picture and Sound Electronics Store has hired Eric to work in the warehouse. He uses a pulley with a hand crank to lift heavy boxes. To lift the box 30 feet, he turns the crank 30 times. Oh, man. All right, so he turns the crank 30 times to go 30 feet. Well, the next one would be 60-60, but it's off the graph, right? But if you think about it, if he does 30-30, couldn't he also do 20-20, right? Or 15-15, or if you want to just do 0-0, you could actually do any of those points. And again, if we were to look at the slope, right, it goes up 5 over 5, up 5 over 5, up 5, or up 15 over 15. All right, the slope is 1, right? The change in y over the change in x is 1, and if you took any of these points, the x and the y value are the same, and you would get 1 as well. 1 for the slope, 1 for the constant of proportionality. All right, what about the challenge zone? Here we go. Every Halloween, trick-or-treaters love going to Christina's house to see her spooky decorations and to get some of her delicious caramel chews. She gives a group of 20 kids a total of 8 caramel chews. All right, so 20 kids gets 80 caramel chews. Okay, so I just have that 1 point. So how do I get another point? Well, if you look at the ratio, 80 to 20, right? 80 to 20, that ratio is 4 to 1. So I can pick any other point on here that is 4 to 1. So how about if I do 40? Well, 40 would go to 10, right? Do you see that, right? 40 to 10, I could do 20. 20 would have to go to 5, which is right in between there. Also, you can see that when I did it, this goes through 0, 0, which means this is a proportional relationship. So just again, let me go over what we had here. We knew that there was the point which was 20, 80, right? So we knew the ratio, 80 to 20, the ratio was 4 to 1, right? The ratio was 4 to 1. If 0 kids showed up at her house, she would give out 0 pieces of candy. So if we're looking at the slope, this is the one I did, right? If we looked at the slope for the whole thing, it would go there, right? Yeah. So this is the change in y is equal to 80. The change in x was equal to 20. The scale makes this confusing because this is 20 over here and that's 80, right? And so this really should go much higher, but they had to make it fit, right? So if we do the change in y over the change in x, we get 80 over 20, which is 4 over 1. So we knew that the y value, whatever it was, had to be 4 times as big because this is a proportional relationship, right? Or I knew that, right, if I went up 80, I went over 20. If I did it again, right, if the graph was big enough, 80 plus 80, or 80 times 2 would be 160, right? And if I did 20 times 2, I would get 40. So another point would be 40, 160. But the graph didn't go that high, so I had to go the other direction, right? And so if I went down, we could even think of it that way if we wanted to. Say, well, let's just reverse this. Let's go down 80 and let's go back 20. And where does that put us? Right back at the origin. That's probably the best way to come up with that other point, because that would work even if it weren't a proportional relationship. Proportional relationships always have to go through 0, 0, but you could have a constant rate of change that's not proportional. So simply repeating the slope going the opposite direction or repeating the slope going the same direction. The problem is we would, like I said, we're we're off the screen, right? We don't want to do that. Okay? Okay, so what was the slope of the line? It was 4/1. Every kid got 4 caramels, right? Okay, that's all I'm going to do on that one. Let's go to the next skill, interpreting graphs of proportional relationships. All right, so a mysterious flying superhero known as Blue Sky protects the good citizens of Newton. All right, why do I feel like I've read this already? Okay, maybe I did it in some preparation. If I did this in a previous video, I'm so sorry, because this definitely sounds familiar. All right, so it says the graph shows a proportional relationship between the number of hours. All right, Scarlett has charged her flying suit and the number of hours she can fly, right? So she charges it for 2 hours and she flies for 4. So what does the point 2,4 represent? If Scarlett charged it for 2 hours, she can fly for 4 hours, right? Okay, easy peasy lemon squeezy. All right, here we have Sasha going to Chicago. The graph shows the proportional relationship between the time she spends riding the train and the distance she travels. So here's our time in minutes. There's our miles. So what do we have? We have 3 minutes goes 2 miles, right? So in 3 minutes, her train travels 2 miles. All right, let's skip up to the next level and see what we have going on there. All right, the graph shows the proportional relationship between the number of days Harper has been memorizing her lines and the total number of lines memorized. So in 5 days, she has memorized 50 lines, right? 5 times 10. All right. By the way, the slope of this line, I know they're not asking you for slope, but we just did that, right? The slope would be up 10/1, right? Up 10/1. Do you see that slope right there? Up 10/1, up 10/1, all the way, right? We go up 5 times and over 5 times, it gets us to 50. So what does the point 550 represent? In 5 days, all right, she will have memorized 50 lines. All righty. Rafi loves to read and discuss books, so he joined a book club. The graph shows the proportional relationship between the time Rafi has spent reading and the number of pages he has read. At what point, what does point T represent? Well, if you go 2 hours, it is 40 pages, right? 2 hours, 40 pages. So that means he reads 20 pages per hour. And again, you'll see if I go up 20, it goes over 1 hour, right? If I go up another 20, it goes over 2 hours. So the slope of this line is 20. That gives us his unit rate of 20 pages per hour, or 40 hours. Sorry, my apologies. 2 hours to read 40 pages. All right, 40 hours to read 2 pages would not be such great reading skills, huh? Okay, Camille is driving a car. Let's see, gallons and miles. 6 gallons, 300 miles, right? 6 gallons, 300 miles. So Camille can drive her new car for 300 miles using 6 gallons. By the way, if we were to do 300 divided by 6, what would we get? We would get 50. So that means that this has a slope of 50. So if I go up 50, I'm trying to go halfway, over 1, right? Up 50 over 1, up 50 over 1. It's kind of hard because I'm supposed to go halfway there, right? All right. Or it's easier kind of to say, well, instead of going up 50 and over 1, how about if I go up 100 and over 2? Up 100 and over 2. So again, they didn't ask us for the slope. The slope would be 50. All right. That is our unit rate. That is our constant of proportionality. What do they have for us in the challenge zone? All righty. Tessa is relaxing on her porch. She sees a snail crawling. She's amazed at how slowly it moves. This is the graph she has. All right, in 30 minutes, the snail moves how far? So here's 30 minutes. So I'm going to go up from 30 minutes. I'm going to go up, and then I'm going to go over. Well, in 30 minutes, the snail has moved 60 feet, right? 60 feet in 30 minutes. If I simplify that, what do I get? I get 2 feet per minute, right? So this would be my rate, all right, my unit rate, which would actually also be my slope, right? In 1 minute, it would go up 2 feet, right? 2 feet per minute, 2 feet per minute. Alrighty, so if you see here, 20 goes to 10, right? Okay, 40 goes to 20, and 60 goes to 30. See how that works? All right, so in 30 minutes, the snail went 60 feet. Alrighty. Okay, well, that's the end of that one. We're going to do one more here together, and that is writing and solving equations for proportional relationships. Before we do anything, just remember, in a proportional relationship, y divided by x is equal to k, which is my constant of proportionality. And remember, the equation of a proportional line is y is equal to kx. That's our proportional equation. All right, remember, if we graph it, it will be a straight line, which we now know means a constant rate of change going through 0, 0. And then we know that if you're in a table, just like points on a graph, y divided by x will always be a constant. All right, just a quick review before we dive in here. Okay, I'm just going to skip down to the nitty-gritty. To travel back 7 years, Patty's time machine needs 14 megawatts of electricity. All right, now it is good to know which one is x. So time is x, and electricity is y. All right, so time is x and electricity is y. Remember, y divided by x is equal to k, and y is equal to kx. So I'm going to do 14 divided by 7 is equal to 2, so y is equal to 2x. So the megawatts will always be twice the number of years. So y is equal to 2x. All righty. The equation that models that relationship, y equals 2x, deja vu all over again. How much electricity does she need to travel back 8 years? So again, time is x. So basically, what are they telling us? They're saying x is equal to 8, and they want to know how much electricity, that's y, right? But y is equal to 2x, and now we know that x is equal to 8, so y is equal to 2 times 8, so y is equal to 16. So that means 16 megawatts are needed because we need twice as much electricity as we need time. All right, how far back in time can Patty's machine travel using 20 megawatts? Okay. So now they're giving us the megawatts, all right, which is y, and they're asking us for x, right? So they're saying y is equal to 20, and they're saying x is equal to what? Well, remember, y is equal to 2x. What did they give us? They gave us 20 is equal to 2x. If we cut both of those in half, we get x is equal to 10, which, of course, you know that the megawatts is always twice of the time, so we're going to divide to get that answer, and we get 10 years. 10 years is what we get. All right? In 2 minutes, Edna can fold 10 bed sheets. Write the equation between x and y. All right, so again, you got to know what your x is. You got to know what your y is. So the time is x, and the number of bed sheets is y. Remember, y divided by x is equal to k. 10 divided by 2 is equal to 5. and y is equal to kx, right? So y is going to be equal to 5x. Does that make sense? Y equals 5x. All right, and then I think they're going to have us go through and do the same thing we did on the previous one. So I'm going to skip over to the next level, and actually I'm going to skip over to the next level. And then I'm going to skip over to the next level because it's all related to that same bed sheet question. Alrighty. Here we go. Let's see what they have in the challenge zone. Oh my goodness. Well, let's see. All right. The equation that models this relationship is 5x. How many bed sheets can Edna fold in 3 minutes? Okay. Well, all right, the amount of time in minutes she spends folding is x, so x is equal to 3. Am I misreading this? Isn't this just more of the same thing? So the answer is simply 15 bed sheets, right? The number of bed sheets that she folds, y, is 5 times the number of times, so it's simply 15. All right, well, I guess it's not going to get any harder than that. All right. Wow. How long does it take Edna to fold 20 bed sheets? Well, now we're going to work backwards, right? If, again, I'll do this last one, even though it's just more of the same thing. Y is equal to 5x. Y is the number of bed sheets, so this time 20 is equal to 5x. Divide by 5, you get x is equal to 4. It's going to take her 4 minutes, right? So when they give you the x, you multiply by k to find y. When they give you y, you divide by k to find x, right? So y is equal to k times x, whereas x is equal to y divided by k. So those are good to know. Figure out which one they're giving you and use the appropriate equation. Ooh, wow, I just looked at this one. All right, this one they're giving you the relationship and they're asking you for x and y. They're asking you for the equation, so this is back to, right, you're going to find k. Remember, k is equal to y divided by x, and then your equation is y equals kx. I guess it's really no harder. It's just they happen to use decimals, which it's okay to use a calculator on this if you want to. Okay? All right, so I just went through skills 8, 9, and 10. I had already done all the others. I'm not going to do a video on the checkpoint because that just is putting all those other skills together. All right, I hope this video was helpful. Remember, I also posted another video where I was teaching about slope, and then I posted a video with Dr. Berger as well. So those videos plus this video should really help you work through this skill and also the HMH assignment, which I gave you. All right, have a great day, everybody. Till next time. Bye.